In this video, we're going to convert a Babylonian number to a decimal number. So first of all, we're going to look at the symbols Babylonians used. So they basically had two symbols, an upright wedge to represent 1 and a sideways wedge to represent 10. And we know Babylonian number system is a base 60 system. So it's similar to our modern number system. It has a place value. So it's a positional number system. For example, if we write down a modern number 1234, when we look at it, we can tell clearly it has 4 decimal places. I'm sorry, 4 places, and each of them has a place value. So ones, that's ones, tens, hundreds, and thousands. Similar to this, a Babylonian number also has place values, but it's not very clear by looking at it how many places it has, this number. So it's kind of confusing sometimes, and if we don't leave a big enough space. So I kind of divide this to, that's 1 place here, and then 1 place here, and then 1 place there. And so we have 4, 1, 2, 3, 4, sort of 4 places. This number has 4 places. But sometimes if we don't put them closer enough, you might think there's another place right here. So, but if we're going to consider these two are together, but in real life, it was possible that they could. If we leave a big enough space, we might think there are another 2 places here. Okay, so we're going to write down the modern number for each place. And this upright wedge represents 1. And this place with a bunch of symbols, and you can see it's more complicated than modern number system, instead of having just one single number. And so here we have 2, the sideways wedge represents, that's like a 20, and we have 8 ones right here. So when we add them together, we have 28. So the second place represents 28 because we have base 60, so you're allowed to have 28 in one place. And over here we have sideways, which is 50, and we have 2 ones, and so add them together we get 52. And the last place has 2 sideways wedge, and that's 20. Okay, so we have these 4 places. So I have to use, not like modern number system, we don't have to put on any comma between them because each place can only has 1 single symbol. But with the base 60, and we have to use comma to separate them, or you leave a big space so we can tell which one is the first place, second place, third place, and fourth place. So now we can mark keep in mind that the Babylonian number system, each place represents either 1, 60, 60 squared, and 60 cubed. Kind of like modern number system, but in modern number system has a base 10. So we have the last digit also represents 1, but the next one represents 10, and the next one represents 10 squared, and then 10 cubed, and so on. So following this pattern, we know that this last digit, last place represents also the same ones. So how many ones? We got 20 ones. But the second place, unlike modern number system, it does not it represents 60, not tens anymore. And so we have 52 of 60s. And 28, the next place, would represent 60 squared, which is 3600. So we got 28 of 60 squares. And this place would be, so we increase the power of 60 from 61st, 62nd, and 63rd. And actually, one you can consider as by algebra. This is sort of like 60 to 0. And any number raised to 0 is 1. Okay, so we have 1 of 60 cubed. And now we're going to add all the, multiply them and add all of them together. So we have 1 of 60 cubed and plus 28 of 60 squared plus 52 of 60 plus 20 ones. And so now we work it out. We add all these together. So make sure you do follow in the order of operations. You will have to find the cubed squared first, and after that you multiply each number with, and we do multiplication, and then we do addition. So you can use a calculator if you want, and we add all of these together, we get 319,940. So that's the modern number to represent this Babylonian number.